Here's the next problem. You have a stone that is projected horizontally with 10 meters per second from 8 meters height. So let's quickly draw that first before we continue. Otherwise, I'll have to continuously keep looking at the problem. So we have a stone that is dropped. It's projected horizontally, okay, with 10 meters per second. So this is 10 from a height of 8 meters. So this height is 8 meters. All right. The stone hits a tower 10 meters away. So there's a tower, there's an additional tower here. Okay, let's put that tower here somewhere. Okay, and this guy is 10 meters away. Yeah, calculate the height at which the stone hits the tower. So we need to... Alright, we need to find out. It's gonna hit over here somewhere, I think. So it's gonna hit here. And we need to find this height. We call it as h. And the angle. So yeah, so the angle at which it hits. This angle. Alright. It's also a fairly simple problem. I want you to try and pause this and do it yourself first. See if you can get the answer. This is pretty much straightforward. It's pretty similar to what we have done so far. So let's begin. We always begin by marking our points. Here is A and B. I'll be doing the physics from A to B. I'll take right direction as positive. Things are not going up now, so I can choose downwards as positive. That makes sense. Okay. My favorite part is always to start from the horizontal. So let me do that. Horizontal. Because there is no acceleration in the horizontal. I just love that. Alright, initial velocity is 10. And what else do I know? Ooh, I know the distance. Oh, I know S. You see, that's why I like to start in the horizontal. Because you immediately understand whether you can solve it or not. We can solve this because we know two things. We know S and we know U. So we can calculate time. Let's do it. S equals ut. So 10 equals 10 times t. So t is 1 second. Done. Bang. Got it. But we need to calculate this height. Well, we can now do the physics in the vertical. Let's see what we get. Let me do it in the vertical. In the vertical, we know, let me use some other color. Let's use blue. In the vertical, we know, well, initial velocity is 0. There is no initial velocity here. We know the acceleration is plus 10 because I chose downwards as positive. And what else do we know? We know the time taken. That's 1. So we can go for S equal to ut plus half at squared. So S is ut at 0 plus half into 10 into t squared. So S turns out to be 5 meters. Ooh, so I've calculated the displacement this way is 5 meters. But I need to calculate this h. Well, the total distance is 8 and this is 5. So the required answer, we have gotten it. That's 8 minus 5. So the height h is 8 minus 5, which is 3 meters. That's the height. Alright, next step is we need to calculate the angle, and to do that, we will calculate the velocities because that will help me directly calculate the angle. Well, we already know that there is one horizontal velocity, that's 10, that's never going to change. We just need to calculate the vertical velocity, which you can do it over here. We'll do it in the vertical itself. I'm doing the physics from A to B. Gosh, I keep forgetting to write that. Anyways, okay, so... Alright. Final velocity, v equals u plus at. V is u plus a times t. So v is just 10 meters per second. That means I also know this velocity, that is 10. Now you guys can easily tell, Pythagoras theorem. Oh, we don't need that, we just need the angle. Both are 10. So the vector has to be 45 degrees. So the angle theta is 45 degrees with the horizontal. Ta-da! Done.